Hello, Sir Gulshan. Hi, everyone. I am Ednalyn Tabadero, and this is my discussion of assignment number 3. I am going to start with functional programming with focus on higher order functions. Higher order functions are functions that operate on other functions, either by taking them as arguments or by returning them. There are functions that create new functions, functions that change other functions, and functions that provide new types of control flow. Let's also discuss JSON briefly. JSON stands for JavaScript Object Notation. JSON is a syntax for storing and exchanging data. The JSON syntax is a subset of the JavaScript syntax. JSON is very similar to JavaScript's way of writing arrays and objects with a few restrictions. Now, let's go to our first higher order function. It is called filter. Filter is a function in the array that accepts another function which it will use to return a new filter version of the array. To better understand this, let's go and look at an example. So we have an array here named students with names and grade. What we want filter to do is to log the students who has a grade of passed. We can do this by using a for loop, but using a filter function, this is the code. So filter, the function filter, will accept one argument that is also a function, and this is called a callback function. The filter will loop through each item in the array, and each item in the array is going to pass in the callback function, and the callback function will tell whether it's true or false. When it's done, it will return the new filtered array. For this case, what we want to be filtered is those students with the grade passed. So let's run this. So as we can see, what is logged in the console are those students with the grade passed. Our next higher order function is a map. It goes through an array. It does not throw the objects away, but transforms them. Let's take a look at the example to see this. So using this same array, what we want map to do is log the student's name. So we can also use a for loop to do this. But using map, we have the map function here, and it also has a callback function. But instead of looking at a true or false, it will include all the items and will return transformed objects that it will put into a new array. So let's see. Let's run this and compare it with filter. Okay. So you see, it has a transformed look as opposed to what filter returns. Our last higher order function is reduce. Reduce summarizes a single value from an array. So let's take a look at an example to better understand this. So now we have a new array name, which is called, we have a new array which is called assets. We have asset names here and the amounts. So what we want reduce to do is to summarize the total amount of assets. We can also do this by a for loop. Okay, so let's see. Let's run this. There. So the total amount is 1,280,000. This is the sum of all amounts of these assets. Now let's compare the for loop with our higher order functions. For me, I think higher order functions are shorter and they're more intuitive. So that means you can easily understand it by reading or by looking at the code as opposed to the for loop. The next topic is object-oriented programming. But before we dive into that, let's have a review first of objects. Objects allows us to represent in code real-world stuff by storing all relevant information in one place. There are two ways to create an object. First is literal notation, another is constructor notation. Methods are properties that hold function values. It is a function associated with objects. Why methods are important? Methods are used to change object property values and also used to make calculations based on object properties. Constructors. A constructor is a way to create an object. Um, using examples later, we're gonna understand these three better. So here, that so this is how you create an object using literal notation by using brackets, and this is how you create by constructor notation. For methods, for this method, Glenn.job accountant, we can change the property value of the object by using a method. So it's this. By using set job, we change Glenn's job from accountant to baker. We can also make our own constructor. We all know that object is a constructor, but by making our own constructor, we can make objects we can make adding properties to the objects less tedious. So this is an example. This is the new constructor that we've made. It's called person, and by using this, we can assign properties to the new object using this format. So now let's dive into object-oriented programming. When we make a constructor, we are defining a new class. In fact, it can be thought of as a type or a category of objects. So an example is this. If we define a new constructor, person, we can think that the objects are class of person. So for this case, baker, accountant, programmer are classes of person. Another concept in object-oriented programming are prototypes. Prototypes keeps track of what a class has or doesn't have. It also tracks what class can do or cannot do. So let's go through an example to understand prototype better. As we can see here, the property scope is not in the new constructor person. But if we run this, Lily will still have a scope. It will still print out count as Lily's scope. This is how prototypes work. But because it's not assigned to Glenn and to Jason, they are returning errors. But we can really use prototypes to apply to all, even though it's not defined in the constructor, for this case, person. So what we're gonna do is have the syntax, which is the constructor, that prototype, that the new property. And this is equals to a function that will, for this case, for this example, it will log the string count because for all of them, for all these persons, baker, accountant, and programmer, they have a scale count. So let's see. Before, when we don't have this syntax, it only applies to Lily, correct? But now that we have the syntax, um, it will now apply to all. So let's try running this and see whether this syntax will now apply to all the the class of persons here. So let's run that. Yes, it does. So that is how you use prototype to apply to all the class. The last concept that I want to discuss about object-oriented programming is inheritance. This allows one class to see and use the methods and properties of another class. Just as class inherits methods, it also inherits properties. So let's go and take a look at an example to better understand this. So what we have here is a function called is a constructor called animal. So under animal we have a class that is called dog. Under dog there are subclasses called dog 1 and dog 2. Um, and then there is a function, there is an animal function that says that will log in the console my breed is which breed, and this pertains to this animal function. But because the dog prototype is we assigned as a new new animal constructor, uh, even though this function is not assigned to this subclasses or classes, it will still print that method. So that ends my discussion for object-oriented programming. The next topic that I will discuss is modularity. So, as good authors divide their books into chapters, good programmers divide their programs into modules. Modules divide programs into clusters of code that by some criterion belong together. Why modules help? The first one is maintainability. A module is self-contained. A well-designed module aims to lessen dependencies on parts of the code based as much as possible so that it can grow and improve independently. The next reason why modules help is because of namespacing. Variables outside the scope of a top-level function are global. It means global, anyone can access. Um, there are actually ways to avoid namespace pollution. Uh, and we can see this by using the examples. First one is using function as namespaces. So look at this sample. You see that the variable names here is on a global is a global variable. Solution here is to use the to use it to put it inside the function. So if you see here, this is the day name function, but instead of having the global variable outside, we have now the local variable inside. So in this case, the other functions outside this function will not be confused in using this variable. So let's see. Let's run this. There. The solution that we have is using objects as interfaces. Our example here places the variable inside the object instead of outside the object. The advantage of modules is its reusability. Reusability, putting pieces of functionality that stand on their own into separate files and module makes them easier to track, update, and share. It for modularity. And this ends my discussion of assignment number 3. Thank you very much.